Graphing that and that. How are they similar? How are they different? Because I gave you a question like that on the project. And I guess most of you figured it out, which is good. Because when you figure it out, as opposed to me telling you, experts say you retain it better. Are they right? So that looks a little different than some other stuff you saw. Oh, come on. Oh, darn it. There we go. Sometimes it just does that. I don't know why. Hey, page 76, you already know that. Okay, when graphing this or that, okay, there's A. That stands for what? Amplitude. Let's go over here. That's D. That stands for vertical displacement, right? Up or down. This is left or right. We used to call it horizontal translation, but now we got a new word for it. It's called, phase shift. So it still is a translation, a shift, vertical displacement, and that is period. Yeah, okay, that was B. So it looks a little different, but this is nicer. You like this better. You just don't know it yet. So that is the period. So when plotting this thing, the period is that, and you're probably going, well, what? Just hold your horses. So when it's in that form, the period is P. So what's going on? Well, here's my formula. Period is 2 pi over B, okay? But this was B. So my period is 2 pi over 2 pi over, well, let's use that one, P. And what can I do with those pi's? What's pi divided by pi? 1. What's 2 divided by 2? 1. So what do I have? I have a 1 over, that's still a 1, over a P. That says 1 divided by 1 over P. We don't want to divide fractions. In grade 8 I told you never want to divide a fraction. You want to multiply it. It'll work if you take the bottom one and flip it. So that's 1 times P over 1, right? Which is just what? It's just P. So the period here is just P. Okay? If you got a 2 pi on the top, the bottom thing is just the period. You want it to look like that. So what's the period here? Hard stuff, eh? And why is that easier than other stuff we've done? Why do you want to graph that thing as opposed to a period of 2 pi? No fractions, right? Well, maybe. But it's going to be like 1.5 or 2.5 instead of, 7/6 pi. Okay? So these ones are nicer. Do it quickly. Find the period. Quick, quick, quick. What's the period? 9. What's the period here? Let someone else play. Reese. Careful. Oh, we got him. Oh, we got him. Oh, yeah, that's not a 2 pi. I know. I want it to look like that, right? So some quick little fractions. I want this to look like that, which means what does x have to be? Pi over 6 is the same as 2 pi over. Yeah, well, whatever you do to the top, do to the bottom, right? And, well, yeah. Okay, I can do that because remember, I'm just timesing it by 1, right? That's the same as 2 pi over 12. Therefore, now it's in a form we want. If it's 2 pi, the thing on the bottom is the period. Okay, so that's the same as what? Two pi over, whatever you do to the top, do to the bottom. So my period is 2. Okay, so those are nicer to graph because, you know, we all hate fractions. How do I graph this thing? How far up or down do I go? You know what? Let's write it like this. 1 sine 2 pi over 10 x minus 0 plus 0. Is that the same thing? Yeah. So let's pretend we're doing it just for practice and review sakes, because, you know, it's just a long. Where do we start? And you might do it your own way. This is the way I'm teaching you to do it. It's the way I think you should do it. But again, if you got chapter 1 stuck in your brain, feel free. You want to start with that. You want to go up or down. Here, I want to go up or down 0 units. So that's where my line is. And then you come over here and look at the amplitude. The amplitude is 1. So it goes up to there. Well, let's put a solid line. I think I did that before. And it goes down to there. The amplitude, 1 unit from that middle line, we call the vertical displacement. And then we want to look at our period to find out, well, okay, this is a sine, so I know it starts there. Where does it end up? Where's that end of that cycle, the end of the period? And we did some pretty fancy stuff before, right? But now, what's my period? Yeah, okay, and we are usually kind of nice. Hey, it goes to 11, so I know the end of that cycle is right there at 10. That's how long the period is. That's 1 complete cycle. And then, what's a sine wave look like? Looks like that, right? Starts there, ends there. Halfway in between, it also goes through 0. So halfway between 0 and 10 is 1, 2, 3, 4, 5. Has a maximum there, halfway in between that 0 and where I started. So that's 1, 2, 3, 4, there's 5, so that's 2.5. And then a sine wave, its minimum is halfway in between that 0 and where it ends. So halfway between there, well, that's another 2.5. Finally, you look at your phase shift. Do I got to move this thing left or right for my final sine graph? No, I don't got to move it nowhere. So that's it. Now, graphing this, we want to graph the points first. We know they're nice and curved, okay? Whoop. Yeah, okay? So those are curved there at the tops, right? So that way we don't get this problem where we come down to that point and, oh, whoops, I got to go up now. I don't go any lower. And we get some nice V's that, you know, I know it's like a preferred shape in your lifestyle, but we don't want it on our sine graphs, okay? All right, so nice and round, okay? Nice and round. That is 1 complete cycle of a sine wave. Is it 1 complete cycle of a cosine wave? Could it be? It doesn't just stop, remember, it keeps going, and wouldn't you know it? Well, actually it goes over there. Now it is. From there to there is 1 complete cycle of a cosine wave, okay? But I graphed it. Okay? Speaking of cosine, here it is. Let's do this a little quicker. What's my period? It's 8. There's 11, 10, 9, 8. Okay, but a cosine wave, again, the amplitude's 1. There's no vertical displacement, starts there, goes to there, goes down to there. Cosine starts at a maximum, and 1 cycle later ends up at a maximum. So its minimum is halfway between there and there. Okay? And if that's 8 for my period, well, that would be 1, 2, 3, 4. That's where the minimum is. I got a 0 halfway between there and there, 1, 2. And I got a 0 right there, halfway between there and there, which is also 2. Okay, do I want to do this? No. Nice and round, nice and round. Do, 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 do. And then just join the points. Keeps going. What's the domain of this? Either of these graphs. All real, right? And I'm not going to use the range word because we got 2 meanings for range. What's the range here? And there's no, I know it's like, why do they use the same word? I don't have that answer, okay? The range is from there to there, from the max to the min. 2 units. Okay, there's no y is less than or equal to, 1 plus or minus 1 up to y is all real. Okay, it's just 2. Don't ask me why. Alrighty? Okay, some more stuff. But again, we've done this. This should be getting kind of easy, I hope. What's the period? Yeah. Okay, that's nice. Because it's under 2 pi, sorry. Okay, but what do I want to do first? I know it goes to 12 units. Oh, look, 15, 14, 13, there's 12. I know the first cycle might end there, depending on my phase shift. But I'll probably want to draw that without my phase shift. That's where I want to start. It's the whole thing shifted up 2 units. 6, that's 0, so each one of these is 1. And at 2, draw that. What's my amplitude? 1, 2, 3 past there, that's as high as it gets. And 3 below this line, that's as low as it gets. So the wave's in between those 2 lines. I've done that. I've done that. Period, I know. Do I have a phase shift here? Looks just like this one, doesn't it? Okay? There's no plus or minus after the x in the brackets. So no, there isn't. It's a cosine, so it's going to start there at a maximum, and 12 units later, it's going to end there at a maximum, because cosine looks like that. Halfway in between, that's where my minimum's going to be. That's 1, 2, 3, 4, 5, 6. That goes down to there. And then halfway between the minimums and the maximums, those are the zeros. Nice handy dandy 1, 2, 3. 1, 2, 3. Roundy, roundy, roundy. Join the points. Okay? That's not a good one, but what it actually would look like is more like that. But hey, it's a lot better than some of you guys' waves. All right? Let's keep going. Do I have a phase shift in this one? Yeah. Okay, so this has got it all. What's my period? Will? I'm going to pick on you, man. What's my period? Yeah. pi over 6 is the same as 2 pi over 12. If that's a 2 pi, then that's my period, okay? 15, 14, 13, 12 might end up there. Well, I'm going to make it end up there first, then I'm going to phase shift it. Again, if you want to think you can do everything at the same time, be my guest. But don't come crying to me when you get like 1 out of 5 on this thing on your test. Number 1, right there. It's got an amplitude of 5. 1, 2, 3, 4 goes right up to the top. And 1, 2, 3, 4, 5 below it. Okay? It's the upper and lower levels, the boundaries of this wave. Period's 12, so it's a sine wave, which looks like that. Okay? Starts here, ends up there, and, well, I'm going to do that last. Okay, halfway in between, it's back there again. So 1, 2, 3, 4, 5, 6. Halfway in between there, I got a max. Halfway in between there, I got a min. So that, what I graphed there is this. I'm just missing the phase shift, right? So if you want to do that and graph it, feel free. Or if I just want to shift that thing, which way? You don't have to graph, you got the points there, so you don't need to necessarily do the line, right? But now at least I can visualize this is how far I want to go. And this is nice because there's no fractions here. These are whole numbers, right? So 2 units, which way? It's a positive, so I want to go left. So 1, 2, that one's going to be maybe a different color. There. 1, 2, that one's going to be there. That guy's there. That guy's there. That guy's there. Nice and around. Okay. So if I had moved that 3 units, that would be exactly on a natural cosine, wouldn't it? And 3 out of 12 is a quarter, which is 90 degrees. All right, got some more to do. A sinusoidal, again, that means sine or cosine. Just because the word sine in there doesn't mean it's not a cosine. Okay. First max is at 210. Okay, well, how's my grid look? 6, so each one of these is a 1. Okay, starts at 0, 1, 2, 3. So 210, there's 11, so I guess that's a 10. And first minimum's at 4, minus 2. Down there. So maybe that's in my way. I don't want to put those there. So it says sine or cosine, and let's look at the questions. Write a sine function, write a cosine function. I got to do both. So which one do you want to do first? Doesn't really matter. Sine looks like that. Cosine looks like that. Okay. Which one does that look like to you? I don't know. Okay, but I know from the max to the min, those are my 2 points. You can look at that section or you can look at this section. It's exactly the same thing. Okay, but I do know that's a maximum, and I know that's a minimum. So halfway in between these 2 points here, I probably want to be a little more exact. Whoa. So what is my amplitude? What is my vertical displacement? That's 10. And that's minus 2. That is a 12. So what's half of 12? 6. So 6 down from 10, or 6 up from negative 2, I don't care which way you think about it, that's the midpoint. That's at 4, right? That's my vertical displacement. So A, y is sine, period, shift. This is, there's one piece of the puzzle. Yeah, hang on. But I was just going to want to graph that thing, and I know now halfway between here and here is there, right? That's right on this line. So, there's half a cycle. What's the other piece of the puzzle I know? Yeah, amplitude is 6. So I did A first, sine wave. Where's this thing going to start? Okay, well if that's there, then this one is here. That doesn't look very good. So that's the starting point for sine. So now I can see what my phase shift is. This thing has been moved 1 unit to the right. So what do I want here? -1. And visually, if you want to see one full wave, there it is. So then what's my period? From here to here, from 1 to 5 is 5 units, right? 4 units, right? 5 minus 1 is 4. 1, 2, 3, every 4 units is my period, and so I just want to write it like that. So you don't have to reduce that. And I noticed some of you guys did on the project. Just leave it like that, okay? I don't care. I know that's pi over 2, but now I can see exactly what the period is. Okay? So that's a sine function. What's the cosine function? I want to go from here to there. So does the amplitude change? Does the period change? No, that's still 4 units, if I can count. 1, 2, 3, yes it is. Okay, does the vertical displacement change? That's still the midpoint of this wave. The only thing that changes is the phase shift. And in this case, it's +1? Yeah, there's lots of ways to do it. +1, if you keep looking at this thing, that would be here. That would be sine. Yeah, but like I say, there's an infinite number of ways we can do this. But let's use the most logical one, okay? This whole cycle, like why would I go minus +3? Right? This is the most logical one to use. It's correct, it's not wrong, but you know. Okay? All right. So, why is it always Johnny? Oh, you're right, that's tomorrow. Oh, okay, you're lucky. Whew. Thanks for stopping me. All right, that's it.
It's really short.